Now let's simplify a few expressions. What is the value of ln1, ln e, and ln e to the fifth power? The natural log of 1 or the log of 1 is always 0. The natural log of e is always equal to 1. Now what do you think ln e to the fifth power is equal to? Notice that the 5, we can move it to the front. So ln e to the fifth power is 5 ln e. And keep in mind, ln e is 1. So this is simply equal to 5. Try these. E to the ln 7, e to the 3 ln x, and 2e 4 ln y. So what's e to the ln 7? Notice that the base of natural log is e. Whenever a base is raised to an exponent that contains the base of itself, those two bases will cancel, and the answer is simply 7. For this one, we need to take the 3 and move it to the exponent of x. E to the 3 ln x is the same as e to the ln x cubed. And so this is base e. These two will cancel, and it's simply x cubed. Now what about this one? This is the same as 2e to the ln y to the fourth. Now this part right here will change to y to the fourth. So the answer is simply 2 times y to the fourth. Try these two problems. So what is 5 raised to the log base 5 of y to the 8? So just like the last examples, these will cancel, and the answer is simply y to the 8th power. For this one, the 3's will cancel, and it's x squared plus 6. So you now know what to do if you ever see something like that on a test. Simplify the following log expression. How would you simplify it? What's log base 3 of 6 minus log base 3 of 2? Whenever you wish to subtract two logs, you can combine them into a single log by means of division. So it's equivalent to log base 3, 6 divided by 2. 6 divided by 2 is 3. Now what is log base 3 of 3? 3 to the what power is equal to 3? This is 3 to the first power. 3 to the first power is 3. So log base 3 of 3 is 1. Keep in mind, you can use the change of base formula. Log base 3 of 3 is the same as log 3 over log 3, which cancels and give you 1. Let's try another example. Try this one. Log base 2 of 12 plus log base 2 of 24 minus log base 2 of 9. So feel free to pause the video and see if you can get the answer. So let's combine it into a single log. So the 12 and the 24 are associated with a positive sign. So it's going to be 12 times 24 on top. The 9 is associated with a negative sign. So we're going to put a 9 on the bottom. So what we need to do is simplify this expression. So what's 12 times 24 divided by 9? Let's break it into smaller numbers. 12 is 4 times 3, 24 is 8 times 3, and 9 is 3 times 3. So we can cancel the 3's, and 4 times 8 is 32. So what we really have is log base 2 of 32. Now how many 2's do we need to multiply to get to 32? Keep in mind, 2 to the 5th power is 32. So log base 2 of 32 is 5. Here's another one. log base 7, 1 over 6, plus log base 7, 6 over 49. So what can we do in this particular problem? How can we solve it? So just like before, since we have two logs separated by an addition sign, we're going to combine it into a single log by multiplying what's on the inside. So it's 1 over 6 times 6 over 49. Notice that the 6's, they cancel. And so what we have left over is log base 7 over 1 of 1 over 49. So we know that 7 squared is 49. So therefore 7 to the negative 2 power is 1 over 49. Therefore this expression is equal to negative 2. So that's the answer. Sometimes you need to change an expression from logarithmic form into exponential form. How can we do that? 2 to the third power is equal to 8. And that's how you can do it. Try this one. 3 to the second power is equal to 9. 5 squared is equal to 25. So that's a simple way in which you can convert a log expression into exponential form. Try these two. Log base A of B is equal to C, and log base 2 of X is equal to Y. So A raised to the C is equal to B. That's how you could change it to exponential form. 2 raised to the Y is equal to X. So now let's convert back to logarithmic form. Convert each exponential equation into a log. So what this really means is log base 3 of 27 is equal to 3. If you work backwards, 3 to the third is 27. So the exponent always goes across the equal sign. The base that has the exponent is the base of the log. So this expression, the next one, 2 to the fourth is equal to 16, is the same as log base 2 of 16 is equal to 4. So the exponent is what the log is equal to. And this is the base of the exponent, which is the base of log. So here we have log base 3 of 18 is equal to x. So x is the exponent and the base is 3. Now let's spend some time solving logarithmic equations. Log base x of 27 is equal to 3. Solve for x. So let's convert it to exponential form. X raised to the third power is 27. So clearly we can see x is 3 because 3 to the third is 27. Therefore x is equal to 3. Try this one. Log base 2 of y is equal to 5. So if we convert it to exponential form, 2 raised to the fifth power is equal to y. 2 to the fifth power is 2 times 2 times 2 times 2 times 2, 5 times. 2 and 2 makes 4, and 4 times 4 is 16. 16 times 2 is 32. So y is equal to 32. Try this problem. Go ahead and solve for x. Feel free to pause the video as you work through these examples. 2 to the third power is equal to what's inside. So 2 to the third power is equal to x plus 5. 2 times 2 times 2 is 8. So to solve for x, all we need to do is subtract both sides by 5. And 8 minus 5 is 3, therefore x is equal to 3.